VPNs. Today I want to talk about site-to-site VPNs and remote access VPNs. To start off, let's talk about site-to-site VPNs. In site-to-site VPNs use IPsec technology to create a tunnel, usually between routers, ASAs, and/or firewalls in two different sites. For example, let's say you have a business that has two offices. One office in Texas and the other office is in Florida. You want all your information that is going back and forth between your offices to be confidential and protected. So you create a VPN that goes from your office router in your Texas location to your office router in your Florida location. Now, between these two offices, there are several routers that your information goes over. These routers belong to your ISP and possibly several other ISPs, or maybe just anyone else that your ISP is connected to. You don't want your information being seen by other individuals outside your business, let alone your ISP provider. So a site-to-site VPN uses IPsec, or Internet Protocol Security, to create a two phases, or really two tunnels is a better analogy because it's easier to wrap your head around, and it's kind of easier to grasp a VPN creating two tunnels. But anyways, your two office routers are configured to know that any information that comes from one site and going to the other is going to be protected when sent out. So this is where we get into the specifics. On phase one, or the first tunnel, the routers are configured to agree upon the type of encryption, the type of hash, and the key to decrypt the encrypted information being sent to it. For example, AES, or Advanced Encryption Standard, is a type of encryption that is very prevalent in VPNs today. AES is one of the strongest encryption types, which is why it makes for a perfect example. So when your Texas router sends a message out to your Florida router, it is first going to request a public key from your Florida router. Then, when your Texas router gets the public key from your Florida router, it will use this key to encrypt the data being sent to your Florida office. But the only way this message can be decrypted is by using Florida's secret key, not its public key, which is why no one else is able to see the message, so you know your message stays confidential. This works vice versa when your Florida office is sending information to your Texas office. So your information is confidential. Now, to go over this one more time, just for the sake of summary. So your office one, or your Texas office, which has your router one, all right, is going to request a public key from your Florida router, all right? Both routers have a public key and both routers have a secret key that they use. So when your information coming from Texas goes to your router one and it's sending off information going over your ISP providers or anybody else connected to your ISP providers and going to your Florida router, it's going to go ahead and encrypt that data within that first tunnel. But first, it's going to request the Florida router's public key, and it's going to encrypt whatever it has with that public key, which is basically just a math formula that helps basically encrypt everything, so it's not plain text being sent over several different routers before it gets to the router of your office. But anyway, so your Texas router requests the Florida key and encrypts it with the public key, all right? And when it gets to your Florida router, it takes that encrypted message and decrypts it with its secret key, okay? So that's what creates this tunnel effect. It's not really going straight to one another via a tunnel. It's still being used by physical routers and connections to them, but it's being encrypted and decrypted through these two routers. Now, when information goes up, let's say to your Texas router and it's going out to your Florida router to get to your Florida network, it's going to not only encrypt the information, but it's also going to encapsulate that into another packet. And that packet has the destination route IP address and a VPN header for this router. That's how this router knows to decrypt it. Okay, and that's how this router knows how to use its secret key for it. Vice versa as well. So, your information is confidential, but how is it protected? Okay, this is where hashing comes into play. A hash takes a text file of any size and creates a string of text that represents that text file. A hash can be used to create a string of text that represents the contents of data being sent over the internet, but you can never run the hash backwards to create what the hash data is. There are many formulas that can hash data like MD5 or SHA. This is important in VPNs because let's say you're using SHA hashing and you send some data using SHA to hash an email, let's say, sent to Florida. The Florida router then uses SHA to have the contents of the email hashed, then compares, that hash to the data that it just hashed, and if the two hashes are the same, it knows it's the exact same packet and the packet hasn't been tampered with. And the router will then accept the packet of data and send it over to the recipient in the Florida office. If the hashes are different, the Florida router will just reject the information and it won't accept the packets of data. Because this means someone along the way got a hold of the data basically and tampered with it. They could have even just changed something by one letter or one binary number. It could be the most minute change. But that one minute change changes the hash. And so that's how you know this is a different document. So now that we've talked about phase 1 of the first tunnel, let's talk about phase 2, the second tunnel of the VPNs, which is basically creating a crypto map. That's just another way of, telling your VPN what data will be encrypted, hashed, and decrypted. So the second tunnel tells the first tunnel what its services will be used on, basically. For instance, let's say for your Texas router, you tell the router a crypto map that everything in the Texas site that goes to the Florida site as a destination will be encrypted and hashed. So everything in the blue over here, which is represented as Texas, will go through your router and will go through all of these other routers before it gets to your Florida. But if its destination is the Florida site, it's going to go ahead and request a key to encrypt the information from your Texas site before it's sent over to your Florida site. And then it will send it over. And then the Florida site, with its router, configured as a VPN device, will use its secret key to unencrypt or decrypt the data that just went through, and then it gets to its location. And this makes it to where no other router or no one else, not even your ISP, is going to know that the data is encapsulated in another packet, and that encapsulated data is also encrypted and hashed. So you're also going to know nobody tampered with this information and nobody seeing what's in it. So for instance, in Texas, if you have some sensitive documentation like accounting information that you need to ship on over to your Florida site, going through all kinds of routers with somebody, I don't know, maybe maliciously on this router wanting to get that information, or just wanting to get information period to leak out online, you're protected because you have the hash and you have the encryption, and it's encapsulated into another packet, so it's even harder to read or to know that it's there. So you're fully protected with the two tunnels. All right, tunnel 1, basically just remember, it encrypts, decides on the hashing, decides on the encryption that it uses, and decrypts. Tunnel 2 of the VPN tunnel is basically just telling it, hey, this is the information that you're going to encrypt, hash, and decrypt. That's all tunnel 2 does. So on your Texas router, it's basically saying, hey, anything from Texas going to Florida, go ahead and encrypt. That's the second tunnel. And that's basically all there is to it. Okay, now let's talk about remote site VPNs. In a remote VPN, a single device instead of a network like a site-to-site VPN creates two tunnels or two phases of security process with a router, ASA, firewall, server, or any other VPN device. This remote access VPN uses TLS instead of IPsec as a security protocol to create the VPN tunnel. This is different from site to site because while IPsec secures projects or protects networks like whole networks or hosts, TLS protects applications, sessions, data to service inside a protected network. Take, for instance, you open up your Chase app on your phone. You open up a VPN from your phone to Chase servers. This secures the application's data and data being entered on that application to a Chase server. You can also open up a VPN from your home to your office. So say you're at home right now instead of at your Texas office, you create a VPN from your house, let's say you're over here, and you just create a VPN going over to your router or your VPN device for your Texas location. But you do this by opening up like some kind of a web browser. So unlike IPsec with remote access VPNs, you can use TLS functions of a web browser and create one secure session at a time. You can technically have multiple secured sessions open at any one time, but your security information in the VPN is only for that one distinct session, and your security only goes by session. So as soon as you end your session on your device, your VPN services would also stop. Anything outside that current web browsing session, while the session is active, would also be outside the VPN. Whereas a site-to-site VPN is always on and always active and includes everything that you do, as long as all your information from Texas is heading towards your Florida site. Or it could also set different parameters as well. But it's basically always on and always protecting. Whereas your remote VPN could be through an app or software. It could also be session-based on a browser. So it's completely different. And it dynamically sets itself up through your web browser. If you're using a web browser like Chase, you're going online in Chase, it'll use a VPN. Otherwise, you can use software or applications on your phone to create that VPN.